Good day once again, my highly esteemed viewers. Welcome to class. Remember the name of our channel still remains Easy Approach to Chemistry. If you have not been subscribing, please kindly subscribe. Press the like button and also help to share. So today we'll be giving you guide on how the forthcoming NECO exam will be, the practical aspect of chemistry. So please pay attention very well and try to understand all the things we are going to be discussing. It's going to be in two videos. The first video is going to be titration, which also called the quantitative analysis, while the other one is going to be on the qualitative analysis, otherwise known as SWOT analysis. So please, you try and pay attention to both of them. If you have any issues or any question with them, ask. I'll be glad to answer you. This is just my own formulation. It's not an just my own formulation, what I predict. So try and understand it very, very well. So, first of all, this is the question before us. Solution A contains 3.11 gram of an acid H2Y in 500 cm cube of solution. B contains 3.90 gram per dm cube of sodium hydroxide. Put into the burette and titrate it against 20 cm cube or 25 cm cube portion of B using methyl orange as indicator. Calculate your burette readings, and from your result and information provided, calculate concentration of B in mole per dm cube, concentration of A in mole per dm cube, molar mass of H2Y. Remember, these are the values we are going to use there under it. So we start first of all by carrying out a simple titration. So this is what you are going to do. This the acid. Remember, you have to add acid into the burette. It has been rinsed with the acid and everything is intact to minimize time. So what we are going to do, we'll try to remove the air bubbles from here. It has been removed. Then we now remove the funnel. Okay, it's exactly at 0. Check the meniscus line, it's exactly at 0. So this one is the acid. Then we'll go for the base. This is the base. You have to use the pipette to take out some quantities. You cannot use a measuring cylinder, you know that. Okay, so exactly at 25 cm cube. Allow it to drain through. Remember, this base is sodium hydroxide we are using. All pipettes have different rate of flow. So just wait patiently, let it flow. In your various flows, once you are giving, all of them will not flow the same at the same rate. So you wait for it to flow through. Remember, the last drop, you must not blow it off. You blow it, it will increase the volume. So it will give you erroneous readings. That's it. So we have it. Then the next thing is to add 2 drops of indicator. Two. Indicator we are using in this titration is methyl orange. Because it's a strong acid against a strong base, you can use any indicator. So without wasting time, we just start our titration and observe the color change. Be stirring it, swirling it. Okay, it has changed. This is the color it has changed to. So it is orange. So let's check it. It's at 25.0 cm cube. So let's draw our table. Titration value. Before you draw the table, write volume of pipette 25.0 cm cube. Titer values or titration to whichever one appeals to you. Just draw a table. 3 will do. You have here. Let me increase it. Let me increase this space. So here we have here initial final burette reading. Initial burette reading. Volume of acid used. You see it. This is how you draw your table. So this is the first, second, and third. cm cube. cm cube. cm cube. So we started from 0, 0.00. So the value we have is 25. 25.00 cm cube. You see it. Then we'll fill it again and do the second one. This is our acid. Okay, it's a 0 mark. You don't need to remove air bubbles because it has already been removed. Discard it here and rinse with clean water. That's enough. Then repeat the process. This is our base. Let's add our indicator. Two drops. 1, 2. Be swallowing it while you are adding. 25.10. 25.10 started from 0.00. So let's, since we still have solutions, so let's do the third and final one. Rinse again with clean water. Ensure you don't make unnecessary errors when carrying out this work. So let's refill the burette. I have to reduce it. She went beyond 25. Okay. Went beyond the 0 mark. That's the main course mark. So we now have to carry out we are doing the final titration. You don't need to do up to 5 or 6. Just do about 3. So just do 3 actually. It's gradually changing, so you start observing it. Let's see. 25.10. 25.10. So you can see we have got our titration, our values. The next is to carry out, we find the averaging. Look at here, 25.00, 25.10, 25.10. As you can see, all of them are concordant. They are all correct. Use this one for your values. NECO marks everything correct. So, but what we are going to use here, there are 2 better ones. 1, 2, 3, 1, 2, 3. So that's how the marks are given. It's unlike why that have 4 marks. So you want to say average. Average volume of acid used 25.10 plus 25.10 over 2 gives you 50.20 over 2, making 25.10 cm3. You see it? This one must always end up in 2 decimal places. So this is how you get your values. This one, you write it like this, you are earning all the marks. 1 mark here, 6 marks here, making 7 marks, 2 marks here, making 9 marks. 9 marks is what you are supposed to have here. But the question is not over. So let us try. I will raise it now so that we continue the calculation. We just keep the endpoint we have because of the nature of our board. So that is how it is. Then the question now says, calculate your direct readings, and from your result, calculate concentration of B in mole per dm³. So let's see. He said solution B contains 3.90 gram per dm³ of sodium hydroxide. So we now say concentration in mole per dm³ equals concentration in gram per dm³ over molar mass. So what's gram per dm³? You have 3.90. 3.90 over the molar mass of sodium hydroxide. Molar mass NaOH, which is, please try and show the how you calculated it. You can do it in this way. 23 plus 16 plus 1. Put it in bracket. Give you 23.90 over 40. You see it? So just do the calculation here. Do the evaluation. Let's see what we have. 23, 20, 23, sorry, 39, 39, 3.90 divided by 40, 0.0975. 0.0975. Look at the unit, mole per dm³. So this one solves that. So the next question says, so we are done with this first question. Next question says concentration of A in mole per dm³. And we have solution A contains 3.11 gram of an acid H2Y in 500 cm³. We cannot calculate that. The only way we cannot calculate it directly. The only way we can do, let's keep this volume of pipettes, volume data value as 25.0 here, 0.10 here. So we can delete here. So Roman figure 2. So the only way you can do it to standardize the solution. This solution is not standardized. We now say 1,500 cm³ of A contains 3.11 gram. Therefore, 1,000 cm³ of A contain X. Cross multiply X times 500 cm³ equals 3.11 gram times 1,000 cm³. S equals 3.11 gram times 1,000 cm³ over 500 cm³. You see it? So 500 go with this, many 2. This one go with this. So 2 times 3, that's 6.22 gram per dm³. Because it's not standard solution. So we have 6.22 gram per dm³. Let's delete this one by retaining our answer. So 6.22 grams, what we have. 6.22 gram per dm³ is what we have for now. About the second concentration of A in mole per dm³. We now say Ca from this one. We now say Ca. Remember we just standardize